Okay, this is Mr. Peterson, and I'm going to be covering section 2.7b for Honors Algebra 2, probably just Honors, but maybe Algebra 2 also. And in this section, we're going to be graphing a line and a parabola and solving the system by finding the place that's on both of them. In other words, these points, there's two of them in this example. They satisfy both the quadratic equation that's up here, function actually, with a y there, and the linear function here. So these are the graphs you'd get if you graph these two functions. Okay, but we're going to be doing this with the substitution method. And I've decided to do just that, so even though it mentions two different methods up here, calculator and otherwise, I'm just going to use the substitution method on this note set. Okay, so you start with the quadratic equation and you solve for y. So let me write that down. Negative 3x equals 3x squared minus y minus 5. And I need to get the y by itself, so I'm going to bring that back that way and the other term the other way. So that takes me to y equals 3x squared plus 3x minus 5. And in short order, we have our y isolated. Now what this means is that this expression over here is equivalent to y. So it's the part that gives this part of the points. And since that is on both graphs, we're going to replace this y with that expression. So that's the next thing you do, is you take this quadratic expression and you replace the y in the linear equation. So here we go. 2x minus y equals 3. Just copy that. And we're going to, in place of that y, we're going to stick this expression. And it's a good idea to put it in parentheses like I just modeled there. So that would be 3x squared plus 3x minus 5. And then we finish it off with equals 3 over here. Okay, now we're going to put this in standard form and treat it as a quadratic equation, which it will be. So what we're going to have here is a 2x minus 3x squared. I'm going to be distributing the negative. Minus 3x plus 5. There's a double negative, negative, and negative there. And then I'm going to bring the 3 over to the other side. Okay, if I put this in order, it's negative 3x squared. The linear parts combine to negative 1x. And these two constants add up to 2 equals 0. I don't like the negative in the front, so I'm going to divide everything by negative 1, which is just going to change all the sign. And you can do that if you have an equal sign. So let me show you what I'm doing. And this has the effect of changing that pesky little negative up front to positive. So now it's 3x squared plus 1x minus 2 equals 0. Okay, so now I have it in standard form, and that took more space than I intended, so I'm going to probably have to keep coming down here into the next space, or you know what, I'm going to come over here with it. I got some space, so I'll use that. Okay, so what I want to do is, before I start out, I want to see if this is going to factor. If it does, I'm going to solve that way. Otherwise, I'm going to resort to the quadratic equation. Okay, so the way you tell here is you take your b squared minus 4 times a and c. So 1 squared minus 4. This is the part that's underneath the square root sign on the quadratic equation. Times 3 times negative 2. And if this gives a perfect square, then we can factor this. Okay, this is going to work here. So what I'm going to do here is come off to the side and put a little star and go ahead and try to factor this. Alright, put 3 on the wings here, and these numbers multiply to give negative 6. Middle number is 1, and I'm trying to find numbers that multiply to give that and add to give this. So I'm going to go with 3 and negative 2 there. You can see these multiply to give negative 6, and they add to give 1. This simplifies to 1 and 1. So now I know this factors into 1x plus 1 and 3x minus 2. which yields two answers, x equals -1, and if you set that equal to 0, you get x equals 2/3. So we have the x values. We know the x part of these points. And to find the y, you simply substitute them into either equation. I will counsel you to do the linear equation. It's usually much easier. So here's the linear equation. I'm going to first of all put x equals -1 in. Alright, the equation was 2x minus y equals 3. And we're going to put a -1 in there. So that's -2 minus y equals 3. Add 2 to both sides and divide by -1. That'll tell us that the x value is -1, yields a y value of -5, and my guess is that's this point down here. I think I was off screen there for part of the time. Okay, let me repeat what I did there. I took x equals -1 and I plugged it into the linear equation and solved it. And now I'm going to do something similar with the other answer, 2/3. So x equals 2/3. And I'll plug that in. So this gives 4/3 minus y equals 3. And I'll subtract 4/3 off both sides. So 3 minus 4/3. And I'll do that on my calculator here. 3 minus 4 divided by 3. And I'm going to hit the math key to convert this. Math, enter, enter. That'll convert it to 5/3. So we have 5/3 there. And I need to change the signs. Divide both sides by -1. So now I know that point is 2/3, -5/3. And I have my two intersection points. These are the x and y values that satisfy both equations. Now all that remains is for us to trace these and see if they actually are on this graph here. So what I'm going to do here is go back up and I'm going to graph both the quadratic equation, and here's the convenient version right here. So I'm going to clear out what was in there and do 3x squared plus 3x minus 5. And then the other one is right here, and it needs to be modified here. So let me quickly get this ready for graphing. Take the 2x over, and we'll change the signs. And I'll graph that one also. Zoom 6. We'll see if this shows both intersections. Okay, that looked out pretty good. Now I'm going to come down here to the answers we had and see if they trace. Go trace -1 inner, and you can see it's at -1, 5. That's good. And that's on the parabola. You can see that up there. That's the quadratic equation. Hit your down arrow and type -1 again, and this time you get -1, 5 on the line. So that worked out. And then I'm going to do 2/3, and that puts me over on the other side, and you can see this is -5/3 there. -1 and 2/3 is that number right there. So that worked out, and I'll hit the up arrow just to confirm it's on the other one also. 2/3 again, and I get the same answer. Same answer both times. That's always the sign you're looking for. Okay, so that does it for page 1 of the notes, and we'll pick up on page 2 on another video.